Good afternoon, everyone. Thank you for joining us for today's webinar. We've just got a few more people joining us at the moment, so I'm going to give it a couple of minutes, and then I will be handing over to colleague Mark to take over and proceed with the presentation. So, yeah, just a couple of minutes because we've just got people joining all the time at the moment. Thank you. Okay, we're at 50 people now, so nice round number. So we'll kick off. So as I say, thank you for joining us today. This is our first webinar from the Surgical Holdings Educational Academy for the year, and this time round we're going to be looking at instrumentation back to basics plus. So we're going to be covering a number of different areas across this afternoon's presentation. So first of all, we're going to look at history and an introduction to surgical instrumentation, talking about the materials and what goes into the materials for surgical instruments and why. And then we're going to move on to rongeurs and have a focus on rongeurs, so particularly Kerrison rongeurs and other spinal instrumentation. And then Mark is going to take us through retractors, so again, specifically spinal retractors. And then finally, we're going to be covering sterilisation containers. So some information around those, maintenance on those. So hopefully that will all be of interest. If you have any questions along the way, please pop them in the chat and we'll take them at the end of the session. Rather than as we go along, although I will keep an eye on it. So if anything comes up that's particularly pertinent, I'll interrupt Mark and we can discuss those further. So as I say, thank you very much for joining us. This session should be around about an hour or so. And after we finish the session, we'll send on the registration details to CPD so they can issue CPD attendance certificates for this session. So, okay, brilliant. I'm going to hand over to Mark now. Thanks, Mark.
Cheers, Dan. Thank you. Hi, everyone. Yeah, thank you for joining today's session. As Dan said, we're going to be looking over the basics of instrumentation, materials and processes, and then looking at spinal rongeurs, different types of rongeurs, and then spinal retraction sets. And before we start, I just wanted to note, obviously, you're on one of our webinars now. We do have previous webinars that we've also recorded. They're available on our YouTube channel, also on our website. So if you enjoyed this session, feel free to go back over and rewatch those. We also have our Surgifix podcast, and as I mentioned, our YouTube channel. So lots of video there as well. Just to update you as well, last year we launched our Surgical Holdings Academy. So this is a live event that we did last year. It was our first event, and that was up in Glasgow. It went really well. We had over 70 people attend, and we ran 3 sessions throughout the day on different subjects. We will be looking at doing, We will be looking at doing another session of this year, at least one, once we get our location set. So we will keep you updated either via email or on our social medias if you would like to attend that. It's a completely free event, and these are CPD accredited sessions as well, so you get your points. Alternatively, obviously, if you struggle for time and you can't get out, why not ask us to come to you? So as you can see from some of the images there, we do run smaller sessions as well. So even if it's only 4 or 5 people, we're more than happy to do that as well. So we can come in and do tailor-made sessions for you guys, educating you on things like materials and processes, identifying faults on instruments, rigid endoscope identification, things like that. All that information, again, is on our YouTube channel. So this is our sales team. I am one of the sales team, also the training lead for Surgical Holdings. We cover the whole of the UK, and all of our sales team are trained to deliver these presentations. So please reach out to us if you would like some of this training, either remotely or we can come to you and do it on site. On-site sessions are a little bit more interactive, which always goes down well. So I have other free resources that you're more than welcome to take us up on. So educational posters, desk mats, pads, pens, all the usual. Even our catalogue is a great resource if you're trying to learn instrumentation. This includes all the pictures, all the sizes and all the sort of features of the instruments. It's a great tool to use. So we're based down in Southend, if you don't know of Surgical Holdings, home to the famous Southend Pier. And we are a British manufacturer and repairer of surgical instruments, rigid endoscopes and orthopaedic implants. So we've been in business for 37 years this year. We have around 65 staff, 25 of those are technicians, and we are a fourth generation of surgical instrument maker, which leads us on nicely to the history of instruments. So Bond Street in London was historically home to several high-end surgical instrument makers, particularly in the 18th and 19th century. Manufacturers of surgical instruments as well as other precision tools were located in central London, and they catered directly to surgeons, hospitals and even royalty at the time. See, things have changed a little bit now. As you can see here, a little bit different to today's process, where you would either go to the company or to your favourite sales rep. Consultants would actually go directly to the workshop where the instrument makers were making those instruments, and they would purchase them directly from them. But over time, these businesses left central London, unfortunately, for many reasons. Some of those reasons obviously being the rise in property costs. I don't know if anyone lives in London, you probably know this firsthand. But Bond Street and surrounding areas become more associated with sort of luxury retail, making it less practical for industrial businesses to remain in central London. Another big problem with industrialisation and need for larger facilities with the businesses. As manufacturing techniques advance, companies needed more space for machinery, staff and storage production, which is hard to find in central London. Many moved to areas with better infrastructure and lower costs. The transport and logistics also played a big part in this. Rail and later road networks allowed companies to relocate to the Midlands and sort of the north of England, where metalworking and engineering industries were already strong. Probably most importantly, the impact of the two world wars. So many businesses had to rethink their locations, some relocating to avoid bomb damage during the Blitz. So this was in the 1940s. But where do materials come from? So I don't know if we've got the young people on the webinar. When's the last time you looked at a periodic table? You're probably the closest to school. But the majority of surgical instruments are made from stainless steel. So stainless steel is made up of a mixture of transition metals and reactive non-metals. So for example, iron plus carbon plus chromium, stainless steel. Also traces of nickel, phosphorus and silicon. As you can see here, so iron plus carbon gives you steel. Iron plus carbon plus the magic ingredient, which is chromium, gives you stainless steel. And as I mentioned, there's also traces of nickel, phosphorus and silicon. So chromium being the important element in this part. Obviously, stainless steel, we all think it's sort of stain proof. It's not. What we actually call it is stainless steel. It has iron within the instrument, so it's always going to want to rust. It's always going to want to get back to its most stable state, which is iron oxide or rust. So very, very important that instruments are passivated. So the passivation, as we said, this is when iron, carbon and chromium, so that's just stainless steel. So naturally the chromium reacts with the oxygen in the air which creates a passive layer protecting the instrument from corrosion. And this is called chromium oxide. So this happens naturally over time. There's no sort of set timescales for this, but we can accelerate this process by using acid baths on instruments. So we use a citric acid bath on all our new instruments, repairs and refurbishments, and this effectively makes that process instant. So not all instruments use the same makeup of elements, so different grades of steel are needed for different instruments. So effectively, this diagram shows the higher the carbon content, the harder the instrument. So as an example, you're going to need a lot more carbon in an instrument like a mallet or an osteotome than you would in a spring forceps. And this hardness is measured on the Rockwell scale, as you can see here. Other medical devices and equipment can be made from other materials, such as aluminium. Things like sterilisation containers, which Dan's going to talk to you a little bit more about later. Certain parts of these containers are still constructed from stainless steel. This is for their strength and durability. Other instruments may be made from titanium. See here, so commonly used in neuro and ophthalmic surgeries. So these instruments are intricate and need to be fine because of their use. So titanium is used for its strength and lightweight properties. As you can see from some of the images here as well, titanium nitrate coatings are also used to make instruments more durable. And some people even use this for identification of specific instruments or sets. Going back to where our materials come from. So obviously there used to be a big iron ore mine in the UK, many of them throughout the country. But the last iron ore mine in Britain, called Florence Mine in Cumbria, so this closed in 2007. And it was the last deep iron ore mine in Western Europe. They've been operating for over 100 years. However, large-scale iron and ore mining in the UK had already declined by the 1980s, with most being closed due to competition from higher quality, cheaper imported ore from places like Australia or Brazil. Today, the UK no longer produces iron ore on a commercial scale, and all iron used in British steel production is now imported. So where does iron come from now? So let's have a look. This is an iron ore map of the world. The top iron ore producing countries are, so Australia being #1. That's the world's largest producer of iron ore, with massive reserves in Western Australia. Brazil, which is home to one of the biggest mining companies in the world. China, which produces a significant amount, but also imports heavily into their country. India being a major producer with a growing domestic demand. And unfortunately, Russia, which has substantial reserves and exports to various markets. Other producers include South Africa, Ukraine, Canada, and the United States. But let's have a look where surgical instruments come from over time. So here we can see some surgical instrument patterns from ancient Egypt, all the way through to about 100 years ago, the early 1900s, through to what we commonly most see today with instrumentation, and then to the future with the Da Vinci robot and robotic surgeries. So as you can see, the patterns haven't changed much over time. But what has changed is the sort of manufacturing processes and the quality of the materials. So let's have a look at patterns and forgings. So there's different types of ways to make surgical instruments. One of the most popular ways is what we call drop forging. So this is a manufacturing process used to create strong and durable surgical instruments by shaping heated metal under pressure, high pressure, or hammering and pressing that instrument. For more precise instruments, things like kerisons, other precise rongeurs, these are manufactured via CNC, which is a machine process. This is a much more intricate process. And this is essential for fine, intricate instruments like scalpels, micro scissors, as I said, kerisons, things like that. The advantage of CNC machining is obviously its consistency. So it's perfect every time. There's no tolerances there. And its repeatability. So it's always the same. With these machines as well, I don't know if anyone's ever seen one of these in action. These use solid blocks of material and they mill the instrument straight from that solid block. So these can give complex geometries that sort of hand making can't do. Obviously, waste is optimized as well with these machines. So these give optimized cutting paths to minimize material waste, making it more efficient. So as we said, there is a focus on rongeurs in this webinar. And as with any presentation, whilst I was researching this, I went straight to Google and searched rongeurs and wasn't expecting to see this when I pressed enter. But this is what came up, which led me on nicely to the sort of next point. So the rongeur actually comes from the French word rongeur, or which means to nibble or gnaw. So the term's quite fitting, as these instruments are used to gnaw or remove small pieces of tissue, bone, or cartilage during surgery. So the word rongeur is used to describe various surgical instruments, often resembling a pair of forceps or pliers with a sharp-edged design used to clip or remove bone or tissue in a controlled, precise manner. So rongeurs appear across many specialties, including ortho, neuro, ENT, and dental. So you can see here big differences in the design depending on what it's used to do, but all do the same job ultimately. There are some other design differences within rongeurs as well. So you can see here, these two have a different box joint. So you can see the rongeur on the right-hand side. So this has a standard box joint, similar to a scissor. So this will always cut back to front, whereas the rongeur on the left has a compound or double action mechanism. So this spreads pressure evenly across the whole jaw. So moving on to probably the most popular type of rongeur, kerison rongeur. So the kerison rongeur was developed in the late 1800s. So the tool was designed to offer a more controlled and efficient method of cutting and removing bone and tissue compared to earlier, bulkier instruments. The instrument was named after Dr. John B. Kerrison. He was an American surgeon who contributed to the design and development of these tools. So Dr. Kerrison was a pioneer in neurosurgery, and his innovations to surgical instruments made a lasting impact on the field. So where are these kerison rongeurs found? So commonly found in laminectomy sets. So during these surgeries, the surgeon will remove the spinous process. Next, the lamina is removed with a drill or bone-biting tool, such as a kerison. And the thickened ligament that connects the laminae of the vertebra below with the vertebra above is removed. And this is repeated for each affected vertebrae. So over the years, the design of the instruments has evolved, with newer models being made in higher quality stainless steels, offering improved durability, precision, and ease of use. Obviously, design features have also been developed. So you can see here at the top, this is a fixed kerison, the one that all of you have seen. Following this was the take-apart kerison, or swing kerison, as it's known. You can see the features. This is much, the take-apart kerison is cleanable. Disadvantages of this kerison is it is not as rigid as the fixed. So you have to weigh up your pros and cons with that. There have been further developments with kerison. So you can see this is called the clean wave kerison. So this is kind of the best of both worlds, really. You've got your rigidity of a fixed kerison and the cleanability of a take-apart kerison without it having to be taken apart. So you can see these cutouts here on the shaft, which make it cleanable. Further innovations with design development include sort of bayonet kerisons. So see here. So this is designed so the surgeon's hands do not obstruct his view for a clear line of sight. And you can even get curved kerisons, as you can see here. And then the picture on the right-hand side, there are insertable kerisons. So you buy one handle and you'll have multiple inserts that can be rotated and changed for size, rather than having 5, 6 kerisons within a set. So let's talk a little bit more about the take-apart kerisons, because these are quite important nowadays. So how to disassemble a take-apart kerison. It's obviously squeezing the handle, keeping that closed, pushing this little gold latch down at the back of the kerison, releasing the handle, lifting the top shank on the instrument there. So that is fully cleanable within that instrument. To reassemble the instrument, obviously realigning the top and bottom shank is very, very important. If you don't get these aligned and you try to shut the kerison, this can cause scoring and binding, which is obviously not very good. Once those are aligned, close the kerison by pulling the triggers together, and then push that lever upwards again. So this is a common thing that we see. Some sites still have non-take-apart kerisons. We get a lot of these in for repair as well, and we've had some of these in the past in for repair that have been used in surgeries. They've come in for sharpening, not necessarily cleaning, but when we've taken them apart, this is what we found. So dried blood, bioburden, all sorts in there that was being used still in the hospital. So this is the argument for a take-apart kerison. It's fully cleanable. So here's a couple of checks you can do. Again, going back to our sort of educational posters and stuff that we can do for you. If you'd like copies of these, just reach out to your local rep or to us directly. We do these in poster form, so you can have them up in your sterile services, theatres, offices, wherever you want them. But this is basically a quick checklist that you can do, and it's available across a multiple of instruments. Also, very, very important is lubricating instruments. Make sure they are fully lubricated. Obviously, if not, lack of lubrication can cause binding, which can damage the passive layer, as we mentioned earlier. This can also hold protein, leading to corrosion and rusting. Another big part of maintaining your kerisons or rongeurs, instruments, whatever it might be, is proper protection, organisation of your sets. So this will prolong the life of any instrument, especially fine instruments like kerisons that are always going blunt. We can offer bespoke fitted baskets for all types of instruments. And as I said, this will prolong the life of any instrument. So moving on, so I appreciate this isn't a kerison rongeur, but this is some punches that we did recently, which kind of applies to kerisons as well. So commonly we see poor repairs out there in the industry. You can see on the left-hand side here, this arthroscopy punch, apologies, has been sharpened, and this came to us as it's not cutting. No surprise there. You can actually see that someone has filed a flat onto the cutting edge, or has taken the cutting edge away completely. And then on the right-hand side, how your cutting edge should look. So really, really, really important that you're sending your instruments to someone who knows what they're doing. We'd even say make sure they've got their ISO accreditations, and go and visit their facilities to make sure they're not in a garage or a shed somewhere. So moving on to spinal retractor sets. Probably the two most popular sets. So this is the black belt and the McCulloch retractor. So these are manufactured in Germany. Again, manufactured on the CNC machine for precision and accuracy. Excuse me, bit of back and forward. So the black belt offers optimal exposure and vision for that anterior cervical discectomy. So this is trusted by and favoured by neuro and orthopaedic surgeons. So this popular retractor has many unique features to assist the surgeon with performing cervical spine surgery. The titanium materials used to manufacture the blades and frame allow the MRI to see through the blades, allowing the retractor to remain in the operating site during surgery. So that's a big benefit to this retractor. The set is very lightweight, obviously, because it is titanium, and it is color coded for quick identification. These sets also come with a black coating as well, anti-glare. So the other popular spinal retractor is the McCulloch, which I'm sure you probably all heard of as well. So the McCulloch retractor has been engineered to aid in surgery by allowing maximum exposure, so similar to the black belt, to the disc whilst using the minimum size incision. So this retractor is specialised for lumbar microdiscectomy. It comes complete with a large range of interchangeable blades and 2 different retractor frames. This set is also suitable for high BMI patients, which is becoming more and more prominent nowadays, as it includes blades up to 120 millimeters in depth, and also a wider rack for wider incisions. So during use, jointed arms fold along the patient's back to allow for unhindered access around the wound. So light reflection is eliminated, as I said, by the black coating. And all sets come fitted in a basket to reduce any loss of components. And also this is a sort of move towards sustainability, not replacing instruments not being damaged. Having these fitted in these custom baskets is a great way to protect your instruments. So I'm going to pass back over to Dan now, who's going to go through a bit of sustainability and talk about containers.
Thank you, Mark. Very interesting so far. I hope everybody is enjoying this information. And if you want to chuck anything in the chat now, we can start taking a look at questions, because so we've got a few slides left. So I just wanted to mention, just first of all, sustainability. The reason, or one of the reasons we've selected Rongeurs to discuss today, is because this is a product actually that is a bit of a problem from a sustainability perspective, because if you don't keep it clean, then it's no good for reuse. So it's really important that you're selecting a design of a rongeur, particularly with things like keratin rongeurs, that allow it either to be taken apart, to be cleaned, or it has some other design features which allow you to do this. So the picture Mark showed, which has the carbonised bioburden, was one, as Mark said, that came into the business and for repair, and we open it up and obviously see this inside. So the alternative for this is you use a single-use device, but that's not something that that we want to do, because obviously we want to be looking to reuse our obviously our surgical instruments. There we go. So in terms of the economy and how we currently deal with sustainability and products, well, at the moment, the traditional model has been a linear economy. So we're taking from the ground raw materials, as Mark's very eloquently described, manufacturing, then using those products, disposing of them, and they just go to waste, to landfill. And obviously that's not what we want. So we want to be looking at a different model, and that's called the circular economy, which I'm sure many of you have heard of now. So that's utilizing raw materials, sustainable raw materials that are from suitably sourced places, designing products that will last and can be reused and reprocessed, obviously producing them, selling and consuming them, but then reusing and repair. So this is obviously a big factor of the circular economy, being able to safely reuse and repair devices, and then ultimately, once they're beyond use, collecting them and recycling them. But really, we don't want to be focusing too much around the recycling. If we can get the repair and the reuse right, and that element right, then obviously these products should just go on and on and on. And we've seen instruments come to us that have been 20 years old that we've been able to refurbish and put back into working condition. So that's certainly an area that we should be focusing on. What are the risks regarding repair? Well, repairs not being done correctly. Mark showed you a picture earlier, which obviously can potentially be a problem for the surgeon, how he's using the device, he or she, and how effective that device will be, but of course also the patient and patient safety. So we don't want that. So I think looking at sustainability and repair of devices is great, but we've got to caveat that with it's got to be to the right standard. So we would advocate as a manufacturer to have those repair standards to the OEM, like to the original manufacturer's standards, utilizing those same machines that are used to make the products. Mark, do you mind clicking on for me? Because I don't know if I've got control. Oh, perfect. And you'll be aware of probably the Green Surgery Report and a recent revision on that. So this is the real focus for operating theatres now, to be looking at best practice, trying to change over from single use where possible, but also bearing in mind the workload this may cause for sterile service departments. If all of a sudden we change everything over from single use to reusable, it's going to give us a whole nother headache. And it might just be possible that actually it's a good thing to have certain devices single use, such as suction tubes, things that are difficult to clean, but also perhaps things that are difficult to take apart and may take a long time. Maybe they'd be better as single use if it's going to save you time to focus on devices that can be reprocessed efficiently. Okay, so when we're talking about what can be achieved, so here is a before and after on an orthopedic mallet. An orthopedic mallet's a great example to show what you can achieve with refurbishment. So we're looking at a beaten up mallet on the left that is something very familiar that we see on a lot of orthopedic sets that come into us. So we can put utilising the skills in our workshop, we can completely regrind, refinish, repolish, and re-weld this mallet to bring it back to this as new specification. And obviously, look, a lovely, bright, shiny mallet there that I'm sure the surgeon would be very proud to use. And quite often we've had remarks that operating theatre staff assume this is new kit. So obviously that's great feedback. But we're not just concentrating on repairing the device. So what's important here is actually completely regenerating and refinishing. So here's some research from the Stainless Steel Association, a paper by Honus and Harrison, and it's really pretty common sense stuff. So if you refinish the device, you want to reduce the surface area effectively. So that will ensure that the device, a smoother finish on the device, has a better corrosion resistance, and we're decreasing the wettability. So that is on a device that has lots of scratches and dents. If you drop water onto the surface of it, it's likely to sit on there, whereas if the surface is really, really smooth, it will disperse. So that's the other advantage, not just looking really good like a new bit of kit, but also improved corrosion resistance. That will also mean less likely that you're going to get retention of things of bioburden and potentially protein on devices as well. So all these are, of course, benefits of refinishing devices. So now on to look at sterilisation and container systems. And we're not manufacturer of these products, but this is something that that we work with another manufacturer, and actually that we've seen a big uplift of interest in the past 24 months or so, and we think that probably is because people are looking at options, alternative to tray wrap that may be better in terms of the sustainability perspective. So, of course, manufacturing a container and using a container consumes quite a lot of energy and water. So obviously you're manufacturing something from aluminium and you need raw materials. But of course, the idea is that once we have these containers, that they last and that they stay in a condition that ensures that the instruments are safe and can be sterilised. But of course, we're not then using loads of tray wrap again and again and again, potentially tray wrap that can't be recycled, that then has to go to landfill. So this is an option that a lot of people are choosing, particularly starting with a lot of heavy orthopedic kit at the moment. And that seems a good starting point if you're looking to get into using containers. So the containers, and I think this is a bit of a similar caveat to the repairs. So they can only do what they're designed to do, as long as they're regularly maintained and protected from damage. Also, that they're used for their intended purpose, so they'll have a weight limit in them. You should also really consider what size basket you're putting into these containers, and if it's suitable for the container size itself. And obviously, you can consult with your manufacturer. Our manufacturer is Bahadir, but other manufacturers also will give you their own guidance on this. So before each use, the container itself should undergo functional and visual inspections, and obviously any container that doesn't pass these tests shouldn't be used. And there's of course elements, consumable products that are used with every use. So the actual locks themselves, and also that click into place, and obviously you can see if they've been tampered, but of course obviously sterilisation indicators as well, and further tray labels which can give you more information. So in terms of the maintenance and care itself, obviously, as I mentioned, there's a criteria and checking you have to go through. But one element here I'm just going to mention is in terms of care products themselves. So we're talking about paraffin, white oil based, biocompatible, obviously very important if you're reprocessing devices, to ensure that there is a biocompatibility risk assessment done on products that are used on these containers. Of course, they should be suitable for steam sterilisation and be steam permeable. So, and if we're going to be applying care products, and similarly as Mark's mentioned, on rongeurs and instruments with articulated parts, we need to be essentially oiling them, and then working those. So if it's on the container, if it's the clamps, oiling them and then working them to ensure that they're smooth, and then this will make sure that you can continue to use them for a long time. So visual and functional checks. So ensure that laser marking is readable and scannable on the actual container lids themselves. This will often be on the clip or the clamp on the side of the container. So ensure that you can see this. It's the only way you're going to be able to identify the container that you're using, because they all look very similar. Expect surface for cracks, fractures, burrs, discoloration, rust. So this is obviously a thing we see a lot. Most of the containers that come into us are in a terrible state, and this might be for sets that have been sent in for refurbishment. We often see lots of dents and damage to gaskets in the container. So obviously this raises a question as to whether they would actually do what you need them to do and maintain a sterile set, of course. So we're talking about checking for loose parts, bent parts, broken parts, and anything that's worn on these that potentially you might be able to get these replaced. So particularly on the plates that hold in the filter as well, you can test those by clicking them in and out and just making sure they hold in place. Checking the coating integrity as well. I've seen recently that there's been some information put out about powder that you may get from if obviously the container itself is aluminium, it's anodized. So if you're using particular chemicals, that could potentially cause a powdering effect on the container itself. So watch out for that, and then raise that with your manufacturer if you need to. So the gasket itself. Oops, sorry, Mark, might have to just go back a couple for me, please. The gasket itself lasts up to 500 sterilisation cycles, checks for cracks and tears around the gasket, and replace it if necessary. So, and test the sealing effectiveness between each use. So that can just be a physical test to make sure that it feels like the container itself is closing and working as it should. Obviously, you're not going to be able to do an in situ test unless you have a testing device, which I'm going to talk about in a minute. So functionality, ensure. Oh, sorry, I just jumped on again, Mark. Functionality, ensure moving parts function smoothly without sticking or rubbing, assemble components and verify compatibility and proper function. And then if any issue is found during these processes, obviously, please put the containers to one side. Potentially they can be repaired, or they may need to be replaced. Finally, and to summarise regarding the containers themselves, so cleaning and disinfection standards must be followed. So obviously locally we have the HTMs. and we need to ensure that containers we're using meet those. So important to check the validation on the containers. Quite a lot of containers, so as we see a rise in popularity, we're seeing more containers be sold into the UK. Generally speaking, they won't necessarily have a 12-month shelf life validation, so that's something you probably want to check, and also ask to see the validation document itself, because that's very important if you're going to be leaving the container on the shelf. Obviously, there's also the legal element. Is the device CE marked? Is it registered with the MHRA? So the manufacturer should be on the PARD database, which is very important from a legal perspective. And then obviously those in situ checks, so appropriate physical and visual inspection should be performed. Don't overload the container. Storage does not exceed the recommended storage conditions, and any issues, repair and maintenance should be reported. And this is something I just briefly touched on. We now offer a container tester. So this is the Conteg. So what this device does is you put your container into the machine. You put the two silicon clamps over the top of the container tester, and it stabilizes the container and tests it for leakage to ensure that there's no or minimal leaking that is in line with what you would expect from the manufacturer. So this is a very useful bit of kit and allows you to do in situ testing on your containers to ensure that they're fit for purpose. Finally, I also wanted to mention baskets because they often get overlooked, and similarly to the containers, although the baskets tend to be made from stainless steel nowadays, we also need to be vigilant and be looking for things like damage to the wire, perforations across the sheet. So where now generally a lot of DIM baskets have perforated sides, if that perforation's damaged, it could be very sharp. So that could mean potentially damaging tray wrap or causing damage to containers. Making sure there's no damage to the spot weld inside the basket, which goes along the rim. That can lead to flaking stainless steel, which obviously you don't want ended up near the patient. And assess suitability for the basket you're using. So obviously, if you've got some really heavy sets, you might need to divide them into two baskets. And if you're using baskets that are bigger, you might want to ensure they've got supporting bars just to give that extra level of protection. And same goes for scopes, really. I think really the scope is more about the scope basket is more about protection of the scope than necessarily the basket, because we found that actually the baskets can often do more damage to the scope sometimes if you've not got a correctly fitting basket that has the correct silicone inserts, then that can actually damage your scope. So not only look out for checking that the basket itself is working, but in the instance of scopes, you also want to make sure that that the silicone's cut correctly and fits correctly. Okay, so that's the end of our presentation. So obviously we've covered a lot of ground. Mark's taken you through historical London and